This video will show how to make some details for a simple snap-together plastic toy car. These details will focus mainly on the wheel well and fender area, and to keep things simple and non-cluttered, I've only modeled this quarter of the car and not included the back end or the cockpit or any of the other details. The car consists of an upper fender and a lower fender, which create a wheel well in which a wheel and of course an axle sit. The car is designed in such a way that the upper fender and lower fender, when they're snapped together, automatically trap the axle between them. This allows for a product which can be easily and quickly assembled. If we look at a side view of the car fender, we see some interesting details. This is the split line between the upper and lower fender. We see that that line goes well above the center of the axle. We also see that the lower fender wheel well cutout actually wraps around underneath the wheel at the front and back of the car. We also see that the wheel well has a back wall behind the wheel and a front wall and a rear wall behind at the trailing edge of the wheel. We will call these wheels the fender liner. We'll call these walls the fender liner, and their purpose is to prevent direct vision into the interior of the car, and this back wall also will serve as a support for the axle. If I explode the assembly, see a little more clearly how some of this comes together. The back wall of the fender liner extends upward almost all the way to the top of the upper fender. This has a deep slot in it that accepts the axle. In addition to this is another rib behind it, which also has a slot to give further support to the axle. So the axle will sit in a cradle formed by two slots. From above, we have the upper fender has a box type of a rib that also has two slots in it, which come down and grab the axle from the top. This way the axle is prevented from moving up and down and fore and aft. In addition to this, we have an interlocking detail at the parting line of both parts. Here we have a step rising up from the parting line of the lower fender, and underneath the upper fender is a similar step that the lower step fits up into. This acts as a registration device between the two parts. All parts are designed so that no slides are required, and the only lifters would be snaps holding the parts together. Those snaps are not represented in this model. In order to avoid the use of slides, the minimum draft angle on all of these parts is 1 degree. All parts were created using the master model technique, where a master model is inserted into each part file and used to parametrically guide the design of the part. And if the master model is changed, the individual piece parts will change as well to guarantee that they always fit together properly. The master model should be as simple as possible, just enough to guide any interactions between the two different parts, and all the major details are then added at the part level rather than in the master model level. So here we see just the outside surface for the upper fender, the outside surface for the lower fender, a surface which will be used to split the two apart, and a surface that will be used to cut away the wheel well in the two fenders. In addition to that, the model contains a solid body for the wheel and a solid body for the axle. The advantage of using this master model technique is it allows multiple parts to be guided by one model, and it also allows multiple team members to work on the same design while coordinating their work through the master model. The subsequent videos will show how to detail out the top fender and the bottom fender.